Good morning, dear students. My name is Ferhan Mazher, and today is 18th April 2021, and day is Sunday. And today we are working on the Physics 5054. It's O levels physics. And today we have set our hearts to solve MCQ paper, and that MCQ paper belongs from the zone 1. So let's start today's paper. So here you have, here we go. The question paper is in front of you. So this is the November 2010 1-1 paper. This paper belongs from zone 1. It's an MCQ paper, and we will have 1 hour to solve this paper. And let's start. Okay, so vernier calipers are shown with the jaws closed. What is the zero error? So here we have the zero error. Let me increase the size so you can see the reading more clearly. And okay. So you can see that the jaws are closed, but still the vernier caliper is showing some reading, and that reading is 0.1. You can see here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So he's saying it's 1 centimeter, so it's 0.1. The zero of the vernier has crossed 0.1, and the fourth line is matching, of the vernier scale is matching with the main scale reading. The fourth line is matching, so the reading is 0.14. So the reading is 0.14. The reading is 0.14. 0.14. So question number 1, C is the option. For question number 1, this C is the right option. Okay, so on your screen, we have the next question. And the next question is, which list contains only scalar quantities? Acceleration, vector. So this is not the answer. Distance, force is a vector, so this is not the answer. C, force is a vector, so this is not the answer. Length, scalar. Mass is a scalar. Speed is a scalar. So D is the choice. Question number 2, D is the right choice. Question number 2, D is the right choice. Then we have the question number 3. A student pulls a piece of tape through a ticker tape timer. Every 0.02 seconds, the timer prints a dot on the tape. First, the tape is pulled quickly, then slowly, then quickly again. So you see this ticker is putting dots on a paper. If you will pull it quickly, the dots will be at a distance from each other. When you will pull it slowly, the dots will be near to each other. And then again, when you will pull it quickly, the dots will be away from each other. So the dots should be away from each other, then close to each other, and then away from each other. So what is the choice? Question is, what is the choice? I think B is the right choice. You see, the dots are away from each other, then close to each other. When it's pulled quickly, the dots will be at a distance from each other, larger distance from each other. When you will pull it slowly, the dots will be close to each other. And when again you will put it quickly, the dots will be away from each other. So I think the B is the right choice. A small stone is dropped from the top of a ladder, falls and hits the ground. It does not rebound. Which speed time graph is correct? So when a stone is dropped from the top of a ladder, its speed will increase. And because it's a stone, so maybe the effect of the air resistance will be not that much. And when it will hit and its speed will increase because when you are having a free fall, your speed increases. So its speed should be increasing, and then when it should touch the ground, all of the sudden the speed should become 0. So I think the best option is C. You see in this part, the speed is increasing, and all of a sudden the speed becomes 0. So I think C is the best option. Question number 4, I think C is the best option. Okay, so now, so big question. So let me reduce the size so you can see the whole thing. Question number 5 is showing on the screen. An aircraft flying at a constant height is gaining speed. So it's flying at a constant height. So the upward and the downward force, they are balanced. But it's gaining speed. It means that the forward force is more than the backward force. The 4 forces acting are L, the lift due to the wings, R, air resistance, T, the thrust due to the engines, W, the weight. Which row is correct? So because it's flying at a constant height, so L and W, they will be equal to each other. And because it's accelerating, so it's gaining speed, so that the T value, the thrust, is more than the air resistance. So I think C is the right choice. Question number 5, C is the right choice. I think C is the right choice. Now we have question number 6. Let me increase the size. Question number 6 is on your screen. A car travels along a road. The driver stops the car by pushing his foot down on the brake pedal. What does not change if he pushes harder on the brake pedal? The braking distance, that will change. The braking force, that will change. The stopping distance, that will change. The thinking distance, oh yes. If you're pushing the pedal very hard, it does not mean that your reaction time has increased. It means that the thinking time has, the thinking distance, the distance which is traveled during which you react, that will not change. So question number 6, D is the choice. The rest of the distances will change. A person of weight 600 Newton at the bottom of a mountain climbs to the top. The gravitational field strength changes from 10 Newton per kg at the bottom to the 9.97 Newton per kg at the top. So the G value is different. At the bottom of the mountain, it's 10, and at the top of the mountain, it will be 9.97. So his mass is unchanged as he climbs. What are his mass and his weight at the top of the mountain? So very simple. If you want to first of all, I know the weight of the person at the bottom of the mountain, and I know the G value at the bottom of the mountain. So I will calculate what is the value of the mass. M will be equals to W by G. Once I know the mass will not change when you go to the mountain top. So if I know the mass on the top of the mountain and I know the G value there, I can also calculate the W value of weight on the top of the mountain. I've done this on a paper. Let me show you my work. And here we go. So question number 7, W1 at the bottom of the mountain, the weight is 600 Newtons, the G value is 10. So I will calculate how much is the mass. M1 will be equals to 600 divided by 10, and it will be 60 kg. So the mass of the person is 60 kg. So when he goes to the top of the mountain, the mass will not change. The value of the G on the top of the mountain is 9.97. So W2 will be equals to M1 G2, and because M1 is the same as M2. So 60 into 9.97, the G value at the top of the mountain is 9.97. You multiply 60 with the 60 with the 9.97, the answer you get is 598.2 Newton. So the weight at the top of the mountain will be 598.2 Newtons. This is question number 7. So let's check. So the weight on the top of the mountain will be 598. Let me check the mark. Let me check the options which we have. So the mass at the top of the mountain will be 60 kg and the weight will be 598. So I think A is the choice. A box has internal volume of 1000 cubic centimeter. When a solid object is placed in the closed box, the volume of the air in the box is now 520 centimeter cube. And the density of the object is 8 grams per centimeter cube. What is the mass of the object? So I know the total volume of this container, and I know the volume of the air here. That is 520. The volume is 1000 centimeter cube. 520 centimeter cube is the volume of the air. So from the total volume, if you subtract the volume of the air, the remaining will be the volume of the solid. So 1000 minus 520, I think it will be 480 centimeter cube. So that will be the volume of the solid. And if you know the density of the solid, that's 8 gram per centimeter cube. And you know the volume, you just multiply them and you will get the mass. So let me show you my work. I've done this question number 8, and let me show. Okay. So here we have question number. So the volume of the object will be 1000 minus 520. That will be 480 centimeter cube. So mass is equals to density multiply volume. Density is 8 grams per centimeter cube, and the volume is 480 centimeter cube. So just multiply them. 3,840 grams. 3,840 gram will be the 3,840 gram. So let me check. So B is the choice. So have a good look. The B is the choice. Question number 8, B is the choice. What affects the stability of an object? The stability of an object depends upon the base area and the height of its center of mass. So what affects the stability of an object? That could be only its base area and the location of its center of mass. So I think B is the right option. Question number 9, B is the right option. So let's reduce the size a bit. A uniform meter rule is balanced by a 4 Newton weight as shown in the diagram. What is the weight W of the meter rule? So here we have the pivot. On the left side, I have 4 Newton force. The moment arm of this force is 10 centimeter. So this force is trying to produce an anti-clockwise turning effect or anti-clockwise moment. This weight of this ruler is at it's at 40 centimeter. This is 50. This is 10 centimeter. So the moment arm will be 40 centimeter, and this weight is trying to produce a clockwise moment because it's balanced. So it means the clockwise moment and the anti-clockwise moment, they are equal to each other, and very easily you can find the W value. So let me show you my work. I have done this on a paper, and then see. Okay, so we have question number 10. So this 4 Newton force is trying to produce anti-clockwise turning effect, and this W is trying to produce a clockwise moment. Clockwise moment is equals to anti-clockwise moment. W into 40 equals to 4 into 10. So W will be equals to 40 by 40 and equals to 1 Newton. So the weight of the ruler will be 1 Newton. So weight of the ruler will be 1 Newton. So A is the choice. Question number 10, A is the right choice, sir. The base of a statue rests on level ground. It is made from stone and is 2 meter long, 2.5 meter high, and 0.80 meter wide. It has a weight of 96,000 Newton. What is the pressure that base exerts on the ground? You see, I know the weight of the object, and I know I can find out the area of the contact of this box with the this statue with the ground, and it's in the shape of a rectangle. So length multiply width, that will be the area, and pressure is equals to weight divided by area. So the contact area will be 0.8 multiplied 2, and that will be the meter square. 0.8 meter multiplied 2 meter, and the weight is 96,000 Newton. You divide it with the base area, which is in contact with the ground, and you will get the pressure. So let's check my work. Okay. So here you can see that I have shown my work. Pressure is equals to weight divided by area. The pressure, weight is equals to 96,000 Newton, and the area is 0.80 multiplied to meter. So that will be meter square. So 60,000 Pascal. So sorry, I mean the 60,000 Pascal. So 60K Pascal, 60 kilopascal. 60 kilopascal is the answer. So this is question number 11, 60 kilopascal. So the right answer will be the D choice. Question number 11, D is the right option. Okay, let's move to the next part. And here we have, it says a reservoir. I thought that I can not. An engineer designs a dam wall for a reservoir. Which factors determines the pressure at X? So the pressure of the water here, that only depends upon the depth of the water here. A, the depth of the water in the reservoir. Yes, that's the right answer. The pressure here depends upon the depth of the water above this point. The surface area of the reservoir, no, it does not depend upon it. The length of the reservoir, no. The thickness of the dam walls, no. So question number 12, A is the right option, sir. The diagram shows a curved track. A ball is released from the position shown. At which point does the ball have the maximum gravitational potential energy? The ball will have the gravitational potential energy and it will be maximum. The gravitational potential energy will be maximum when the ball's height from the ground is maximum. So I think that is at point A. Here the height from the ground is maximum. So here the gravitational potential energy is supposed to be maximum. So A is the choice, sir. When one radium nucleus decays, its mass decreases by 8.8 expo minus 30 kg. How much energy is equivalent to this loss in mass? Speed of light is 3 expo 8 and 3 expo 8 meter per second. You know, it's a very famous equation, Newton's equation, E equals to mc square. E equals to mc square, where E is the energy which will be produced, m is the mass which is converted, who has converted into energy, and c is the speed of light. So simply E equals to mc square you have to use. Let me show you my work. I've done this work, and here, increase the size. So here we go. E equals to mc square. So E will be equals to mass value is 8.8 expo minus 30 kg, and the C value speed of light, that is 3, and that is 3 expo 8 multiply 3 expo 8 because it's square, C square. So when you multiply 8.8 expo minus 30 with 3 expo 8, so you will get the answer 2.64 expo minus 21. You again multiplied with 3 expo 8 because there's the square of the C value. So the final answer will be 7.9 expo minus 13 joules. 7.9 expo minus 13 joules. So let's check the marking scheme. 7.9. So 7.9 expo minus 13 joules. So D is the answer. Question number 14, D is the right answer. The energy output of a generator depends on its efficiency, and the energy input which sets of values is correct. So here the efficiency is given, the input energy is given, and some output energy is also given. So I can find out I will use the formula, output energy is equals to efficiency multiply the energy input, and that will give you output energy. And if the output energy in the question given and the energy in output which comes from my calculation, if they match with each other, then that will be the correct statement. So in all the options, efficiency is given, energy input is given, you simply multiply them and you will get the output energy, useful output energy. And by knowing I will compare with the given values. If my calculation and the given value matches, then it will be, and that it will be the answer. Then it will be the answer. So let me show you my work. So here we go. It's question number 15, I think. Yeah. So the output energy is equal to the efficiency multiply the input energy. And in all the 4 options, we know the input energy. The efficiency for the first part is 0.1 multiply 50. That will be 5 joules. And he gave us 25 joules. Output energy will be 0.2 multiply 30, and that will be 65 joules. And they also, sorry, 6 joules. And they also told us that this will be the 6 joules. So here the given answer and my calculations answer is same. So that will be the answer B, 6 joules. Output is equal to 0.4 multiply 120. This the answer of the output is 48 joules, whereas the book says it's 30 joules, so they are not matching with each other. Output for the D option, output equals to 0.6 multiply 60, that's 36 joules. But in the question they gave 24 joules, which means they are not matching. The only input output energy which I calculated and it is given in the question in the B option, they matches 6 joules and 6 joules. So B, 6 joules and 6 joules. So B is the option. Question number 15, B is the right option. I hope that you have understood how I came to this answer, that the B is correct. Okay. So B is the choice, question number 15. A liquid evaporates rapidly. Why does this cause it to cool? Because you know when evaporation is happening, the molecules which have the larger kinetic energy, they leave from the surface of the liquid, leaving behind less energetic molecules. That's why the average kinetic energy of that liquid drops and the temperature of that liquid also drops. So I think that air molecules remove heat by contact with the liquid surface. That's not right. Energy is lost by convection. That is not right. Some of the most energetic molecules leave the liquid. This is the best answer. And the molecules have less room to move around. That's not right. So question number 16, C is the right choice. The tubes inside solar heating panels use the sun's radiation to warm water. Why are the tubes painted black? We paint them black because black is a very good absorber of the infrared radiation. So that's why we paint them black. So A option is black surfaces are surfaces absorb radiation well. That is right answer. Black surfaces conduct heat well. That's wrong. Black surface emits radiation well. Yeah, that's right. But here we are trying to absorb the heat. Black surfaces reflect radiation well. That's wrong. So A is the perfect answer. Question number 17, A is the right answer. The diagram shows a clinical thermometer. The factors affects the sensitivity of the thermometer. The constriction has no effect on the sensitivity of the thermometer. No, and the diameter of the bore, yes, it has the effect on the sensitivity of the thermometer. The length of the glass tube, it does not have any effect on the sensitivity. The thickness of the glass tube, it does not have any effect on the sensitivity of the thermometer. The only thing which affects the sensitivity of a thermometer is the diameter of the bore. So B is the choice. Question number 18, B is the right option. Question number 18, B is the right option, sir. I need to reduce the size. Okay. A hot liquid is poured into a beaker. The graph shows how its temperature changes as it cools towards room temperature. You see, so this is moving towards room temperature. Its temperature is higher. It's a liquid at higher temperature and it's cooling down. So when the graph, which process are taking place at the region X? So here, when the graph becomes flat, it means that a state change is taking place. When the graph becomes flat, it means that the state change is taking place. So if the state change is taking place, so it was a hot liquid, so it means it's converting into solid. And during that solid evaporation continues to happen. So D is the right option, sir. Solidification and evaporation. So because it's a hot liquid and here the cooling curve has become flat, whenever the cooling curves become flat, it means that the state change is taking place. And it's cooling down, it means the liquid will convert to solid. And when this process will be happening, the evaporation will continue to happen. So D is the right choice. Question number 19, D is the right choice. What is caused by the thermal expansion of a substance when heated? The sentence is very tricky. What is caused by the thermal expansion of a substance when heated? A decrease in the resistance of a tungsten filament lamp when switched on? No, that's wrong. That's wrong. Because a decrease in the resistance do not decrease if it becomes hot. A rise in the pressure of a gas trapped in a gas cylinder placed in a hot water. So a rise in the pressure of a gas trapped in a gas cylinder placed in a hot water. You see here, we don't know whether the piston is movable or it is fixed, so we are not sure. The blowing of the fuse in a circuit when the current becomes too large, here it does not just heats up, it melts. That wire melts. So the blowing of the fuse in a circuit when the current becomes too large. So it's not just expansion, the state changes from solid to liquid. That's why it melts. So the D option is the upward movement of the air above a Bunsen burner when it is lit. So that can be the right answer, because you see here, when you provide heat, the air molecules, they move away from each other, and this is due to the expansion, the thermal expansion. So when you provided heat, the air molecules move away from each other. So the air will become less dense and it will rise upward. So this is a good example of what is caused by the thermal expansion of a substance when heated. So the gas will move upward when it's heated. So D looks the right choice. Question number 20, D is the right choice, sir. This is the choice. So next question. The next question on your screen is showing. So here we have using an experiment. Which row correctly describes the waves after they are reflected from the surface? So when they are reflected from the surface, their speed do not change, their wavelength do not change, and their frequency also do not change. Their wavelength even don't change. So when they will be reflected, their frequency will not change, their speed will not change, and their wavelength will not change. But one thing which will change is the direction of the water waves or direction of the wave fronts. Okay. So the speed of the waves, that will remain the same, and the wavelength will also remain the same. So D is the right choice. Question number 21, D is the right choice. Okay, so here we go. I can increase the size a little bit, so it becomes easy for you to read and understand. A ray of light strikes the surface of a glass block at an angle of incidence of 45 degrees. The refractive index of the glass is 1.5. What is the angle of refraction inside the block? You see, I know the angle of incidence which was formed in the air. I know the refractive index. And what is the angle of refraction inside the block? Very simple. You know, sine I by sine R, that is equals to n value. Sine I by sine R equals to n. I know the value of the I, that is 45 degrees. So sine 45 divided by sine R equals to 1.5. So from there, you can do the calculation. I have done this, and let me show you my calculation so it will become easy for you to solve this paper. So here we go. N equals to sine I divided by sine R. 1.5 equals to sine 45 divided by sine R. I will take sine R to the left side of the equal sign, and 1.5 will come downstairs. So on your calculator, you will write sine 45 equals to divided by 1.5 equals to, and that will be 0.4714. So sine R equals to 0.4714. If I will make the R alone, the sign will go on the other side and it will become inverse. So you will have R is equals to sine inverse 0.4714. And the final answer of the angle of refraction will be 28. Question number 22, A is the right option. Let me check the marking scheme, and then we will see what I can do. So I had the R is 28. So R is 28. So question number 22, A is the right choice. Question number 22, A is the right choice. An object is viewed through a concave diverging lens. What is the correct description of the image form? You see, whenever the image is formed by a diverging lens or by a concave lens, the image formed will be always virtual. The image formed will be always upright, and it will be diminished. Why it will be diminished? Because the size of the image will be smaller than the size of the object. So when you see an object through a concave or diverging lens, the image formed will be virtual, it will be upright, it will be diminished. So question number 23, D is the right option. Which pair of emissions travel with the same speed in the air? All the electromagnetic waves, they travel with the speed of light. So alpha particles and the gamma rays are part of the electromagnetic spectrum, but the alpha particles are not. Gamma rays and infrared waves, yes, they both are from the electromagnetic spectrum. That's why they both will have the same speed in the air. So question number 24, B is the right option, sir. B is the right option. Question number 24, B is the right option. Then we have the next question. During a thunderstorm, there is an interval of 1.70 seconds between an observer seeing the lightning and hearing the thunder. The speed of the sound is 340 meters per second. What is the distance between the observer and the storm? You see, I know the speed of the sound. I know the time it took from where it was produced to reach you. So very easily you can find the distance between the the observer and the storm. So let's check. Let's check them. I've done this on a paper. So here you go. So question number 25, distance is equals to speed multiplied time. Distance is 340 and multiply 1.70. So 578 meters. Question number 25, 578 meters. Question number 25, 578 meter. Let me check. 578 meter. So C is the right choice. Question number 25, C is the right choice. A metal ring screens a piece of equipment from a magnetic field. So here we have an iron ring, and if the magnetic lines will come, they cannot reach the center of the circle. They will travel through the walls of this ring, and from the other side, they will go out. So which metal should be used for the ring and why? This ring is always made of iron. And why we use the iron? Because it absorbs all the magnetic rays and pass through its body, and then it exits them. So what it says, the metal should be made of iron. The metal carries the field lines around the equipment. Or the second option is iron, the metal is non-magnetic. No, the metal carries the field lines around the equipment. C is the best option, sir. Question number 26, C is the option. The metal carries the field lines around the equipment, and the metal is iron. So C is the right option. Question number 26, C is the right option. Okay. So we have to reduce the size. A negatively charged sphere X is brought up to an identical uncharged sphere Y. The spheres do not touch. Sphere Y is earthed by touching it with a finger, which is then removed, and sphere X is then removed and then moved away from the sphere Y. What is the final charge, if any, on the sphere Y? So let me show you. So here I have drawn what the situation will happen. In the step 1, you can see that uncharged sphere Y, and we have a charged sphere X, and the charged sphere X is brought near the uncharged sphere Y. So because the X is negative, and due to this negative, the left side of the Y, it will deficiency in electrons. All electrons have gone to the right side, and then you touch the right side with your finger, or you provided earthing, a path for the earthing. So the negatives on the left, on the right side, the negatives on the right side, when the earth will touch, earth wire will touch here, they will go to the ground. And then you broke that earth wire, and then you remove the first sphere. So now you will notice that the sphere Y has totally become positive, because its electron by mistake or by chance has gone to the ground. So I think this is the 1, 2, 3. So this is the basic shape at the end which you will get. Okay. So I think B is the option. B is the right option, sir. A battery is used to light a 24-watt electric lamp. So I know the power, that's 24 watts. The battery provides a charge of 120 coulomb in 60 seconds. What is the potential difference across the lamp? So I know the charge value, I know the time, I can find out the current I value. Once I know the I value, I know the weight of the electric lamp. Sorry, I know the power of the electric lamp. And P is equals to IV. If I know the I know the power, I can calculate the voltage. So let me show you my work. I have done this on a paper. Let me show you this numerical. I've done this numerical. So here we go. We have done this. This is question number 28 coming on your screen. So I is equals to Q by T. I know the charge value, that's 120 coulomb divided by 60 seconds and the 2 ampere. So the current flowing there is 2 ampere. The power is 24 watt and P is equals to IV. So V will be equals to P divided by I. The value of the power is 24 watts and the value of the current is 2. So the final answer will be 12 volt. This number here, by mistake, I wrote here ampere. This is not ampere, this is volt. It's supposed to be volt here. Let me correct it. Just give me a minute and I will correct it. So by mistake, I wrote there. I just need a second and this will be correct. So here I need to put V. Okay. So that's it. By mistake, I wrote okay. So 12 volt. So hopefully you have understood that how this numerical is done. So the Q and T value was given. So I found the value of the I, that's 2 ampere. The power was given. I know the current value. So I can calculate what is the value of the, I can calculate easily what is the value of the, voltage. Question number 28. I hope you have understood this numerical and question number 28. So what's the choice? B, 12 volt. 12 volt is the answer. Hopefully you have understood. Okay, so we are moving to the next question. The next question is, the diagram shows a simple electric circuit. Which road describes the charge on an electron and the direction of the electron flow through the resistor? So the charge on the electron is negative and the electrons do always flow from the negative of the battery towards the positive of the battery. Electron flow always flows from the negative terminal of the battery to the positive terminal of the battery. So the charge on the electron is negative and the direction of the electron flow will be from negative to positive. So I think A is the choice. Question number 29, A is the right choice. When 3 identical resistors are connected in series, their combined resistance is 6 ohm. So these three resistors in the first figure, series connection, they are identical. So their resistance is equal to each other, R, R, R. So their equivalent resistance, you can very easily find out R plus R plus R, that will be 3R. And he said that the resistance is 6 ohm. So 3R is equals to 6. So R will be equals to 6 divided by 2. So 6 divided by 2. So each resistor is of 3 ohm. And then we connected them in parallel to each other. So when you connect them in parallel to each other, you can find their equivalent resistance very easy. 1 by R equivalent is equals to 1 by R plus 1 by R plus 1 by R. Let me show you my work. I've done this on a paper. Okay, so here we go. So when they were connected in series, they are identical. So R equivalent will be R plus R plus R. That will be 3R. Equivalent resistance is already given. That's 6. So the R value will be 6 divided by 3. That will be 2 ohm. Now you connected the resistors in parallel to each other. So the equivalent resistance I can very easily calculate. 1 by R equivalent is equals to 1 by R plus 1 by R plus 1 by R. So 1 by R equivalent is equal to 1 by 2 plus 1 by 2 plus 1 by 2. So 1 by R equivalent is equals to 3 by 2. So cross multiply and R equivalent value will be 2 divided by 3. 2 divided by 3 ohm. So 2 divided by 3 ohm. So let's check. 2 divided by 3 ohm and 2 divided by 3 ohm. The B is the right option, sir. Question number 30, B is the right option, sir. Okay, so let's move to the next part, and the next part is showing on your screen now. He says, many electrical appliances have metal cases. To prevent the case from becoming live with the possibility of an electric shock, the earth wire of the electric cable is attached to the case. How does the earth wire prevent an electric shock? So different options are given. It allows a current to flow to earth so that appliance continues working. That's wrong. It do not allow the appliance to continue working. If it continue working, then it's still dangerous. It allows a large current to flow to earth, blowing the fuse. Yes, this is the answer, I think. Question number 31, I think this is the best. This is the best answer written there. Then it says it prevents the fuse from blowing. That's wrong. It reduces the current to a safe level. That's wrong. So B is the best option. Question number 31, B is the best option, sir. Okay. So here we go. Two parallel vertical wires P and Q are a small distance apart in air. There is a downward electric current in both the wires. A force acts on Q owing to the current in P. This force is perpendicular to the wire Q. What is the direction of the force on the Q? You see, when you have two parallel conductors and the direction of the current is same. When you have two parallel conductors and the direction of the current is same in both of them, they will attract each other. So if the direction of the current is same in parallel conductors, they will attract each other. So I think D is the right option, sir. D is the right option because the P will be attracting the Q. So D is the right option. What does not alter the size of the turning effect on the coil of an electric motor? So here is very important word, the size of the turning effect. Not talking about the direction, he's talking about the size of the, means the magnitude. The direction of the current in the coil, yes, direction of the current does not affect, direction of the current decides the direction of the turning effect. it does not decide the direction of the current, does not decide the size of the turning. So I think A will be the best option, but let's check the other ones also. The number of turns in the coil, they affect the turning effect. The size of the current in the coil, that also affects the turning effect. The strength of the magnetic field, yes, that also affects. The stronger the magnetic field, the more will be the turning, the more will be the turning effect. So A is the right option. Question number 33, A is the right option. Okay, so need to reduce the size a bit. Still not pretty. Okay, so now we have. The diagram shows an AC generator connected to an electrical circuit load resistor. Which statement is correct? The direction of the potential difference across the load resistor is always the same. That's wrong because it's a generator. So the potential difference will not be always the same. Direction of the potential difference will be changing. The size of the induced EMF depends on the number of turns in the coil. That is true. That depends upon the number of the turns in the coil. The size of the induced EMF does not change as the coil turns, it changes. It becomes zero, it becomes maximum, it becomes a mediocre value, and then it also becomes zero when the coil is vertical. The size of the induced EMF does not change as the coil turns, it changes when the coil turns. Winding the coil on a soft iron cylinder makes no difference on the induced. That's wrong, because when you put a soft iron cylinder and you then wind the wire around it, the magnetic field will become very strong and you will have a larger EMF. So the only thing which do not affect is the direction of the potential difference. A choice. Question number 34. Sorry. He says which the direction of the potential difference across the load is always the same. No, that is wrong. Question number A is wrong. The size of the induced EMF depends upon the number of the turns on the coil. Yes, on this it depends. So try to understand again. So we were looking for which statement is correct. The direction of the potential difference across the load resistor is always the same. That is wrong. The size of the induced EMF depends on the number of turns in the coil. That is right. So that's our answer. C is the size of the induced EMF does not change as the coil turns. It changes. So it's wrong. C is also wrong. Winding the coil on a soft iron cylinder makes no difference to the induced EMF. That is wrong. It makes the difference. So B is the choice. So the answer now coming, the question which is coming on your screen is a very important question because many times you have to write this one. Electric power cables transmit electric energy over large distances using a high voltage alternating current. What are the advantages of using a high voltage and of using an alternating current? You see, why we use the high voltage? Because when you use high voltage, the amount of current decreases, and due to the reduce in the amount of current, what happens? The power loss or energy loss in the cables, that is reduced. So less energy is wasted in the cable. And why we use alternating current? Because for this purpose, at the power station, I will need a step-up transformer, and near the consumer in the city, you will need a step-down transformer to reduce the voltage. So we will require transformers, and you know the transformers, they only work on the alternating current. Automatically, they work on the alternating current. So less energy is wasted in the cable, and the voltage can be changed using a transformer. Yes. Why you use alternating current? Because the transformer works on the alternating current. Alternating current. So I think D is the right option. The diagram shows a beam of electrons entering a magnetic field. The direction of the magnetic field is downwards towards the bottom of the page. In which direction does the deflection of the electrons occur? So I will use the left hand. So take your left hand, stretch these fingers like this. They should be perpendicular to each other. And you remember this thumb is FMC. So this thumb is F force. And this index finger is magnetic field. And this middle finger is the flow of the current. So because this left hand rule is not applicable on the electrons, this is for the positive charges. So if the electrons are going towards left, then the conventional current will be towards the right. Okay. So this law is not applicable on the electrons. So I will take the conventional current. If the electrons are going towards the left, the direction of the conventional current will be towards the right. So the magnetic field is down towards the bottom of the page. The current is going towards the conventional current. The electrons are going towards the left, but it means that the conventional current is towards the right side. So my middle finger is towards the right side. My thumb is pointing into the screen. Into the screen. So into the page. A is the answer. A is the right answer. A is the right answer. So page, I hope that you have understood that how I have used the left hand rule. So the electrons will be deflected into the page. So for applying this law, you see the electrons were going from right to left, but that law is not about the flow of electrons, it is about the conventional current. So if the electrons are going from right to left, the direction of the conventional current will be from left to right. So that's why when I applied the left hand rule, I took the direction of the current, conventional current, from left to right. And the magnetic field was going from towards the bottom of the page. And my thumb is pointing into the screen or into the page. So A will be the choice. Question number 36, A is the choice. The diagram shows an alarm system in which the switch S is shown closed. So what happens when the switch S is opened? Okay, so what will happen when the switch S is opened? You can see this switch S. When it's closed, the current is flowing through this coil, this iron core, and this coil. This will become a magnet, and they will attract this iron piece, and it will remain in the air. So this path for this valve, the path of the current for this valve is incomplete. But if you will open it, the current flowing through this coil, this iron core and this coil will stop. This will be no more magnet. So this iron piece will be not attracted upward. So under the influence of its weight, it will fall down. When it will touch this metal, the path of the current will be completed in this second circuit, and this bell will ring. So the question is, what happens when the switch S is opened? If you will open the switch S, the iron will drop and the bell will ring. The iron will drop and the bell will ring. So question number 37, I think A is the choice. I hope that you have understood. A is the choice. Okay, so here we have. A student investigates a radioactive source that emits only alpha particles, without any source nearby. And the detector shows a low reading. The source and thick cardboard are placed near the detector as shown. What is the reading on the detector now? You see this alpha particles are involved. The penetration power of the alpha particles is very low. In air, they can only travel 4 to 5 centimeters. So they are stopped by the air. So then you put the cardboard between the source and the detector. So then the alpha particles, their penetration power is very low, so they will not be able to pass through this cardboard. So the reading on the detector will drop to the background radiation. So the reading on the detector will be very low and it will be equal to the background radiation, because now the alpha particles are not able to read the detector. The penetration power of the alpha particles is very low. So question number 38, the detector reading should be low, and the reason is the background radiation is detected. So I think A is the choice. Yeah. Question number 38, A is the right choice. I hope you have understood. So let me show this question. Okay. So question number 39 is showing on your screen. Nitrogen 715 is a nuclide of nitrogen. How many electrons are there in the neutral atom of nitrogen 715? So the number of protons and number of electrons in the neutral atom are equal. So nitrogen 715 means that there are 7 protons in the nitrogen. So the same number of electrons will be there. So there will be 7 electrons. So I think A is the choice. Question number 39, A is the choice. So question number next 40 is on your screen. The table shows details of 2 samples of radioactive nuclide X and Y. So there are 2 different radioactive materials. One is X. It's 16,000 number of atoms are present when you started your observation, and its half-life is 1 day. So when 1 day has passed, the value of the atoms present there, they will become half. The number of atoms present there, they will become half. The rest will decay and convert into something different. The nuclide Y, its number of atoms are 2,000 and its half-life is 2 days. So after every 2 days, its number of atoms will be left. Half of the atoms will decay and half will be left. After how many days will the number of atoms of nuclide X be equal to the number of atoms of the nuclide Y? So this trick, I have done this. Let me show you my trick, how I have done this. Here we go. So you can see here, I have drawn a grid. I have written 0 day, 1 day, 2 days, 3, third day, 4th day, 5th day, 6th day, 7th day, 8th day, 9th day, 10th day. So here is that sample X. Its half-life is 1 day, and number of atoms at the start of the observation are 16,000. So when 1 day has passed, it will become 8,000. Another day will pass, it will become 4,000. Another day will pass, it will become 2,000. Another day will pass and it will become 1,000. Another day will pass and it will be 500 and then 250. And further 1 day will pass and it will become 125. So you see the half-life of the X is 1 day. So after every 1 day, its atoms are becoming half of the previous value. So the sample Y, its half-life is 2 days. And when the 0 day, there were 2,000 atoms. So when 2 days will pass, it will become 1,000. Another 2 days will pass, it will become 500. And another 2 days will pass, it will be 250. Another 2 days will pass, it will be 125. So on the 6th day, you can see the number of atoms of the X and the number of atoms of the Y, they are equal on the 6th day, 250, 250. So this is how you do the half-life questions. You draw a grid. Actually, the sample X, its half-life was 1 day. So after every 1 day, its number of atoms, half of them will decay, the half are left. And for the Y, the half-life is 2 days. So after 2 days, its sample, its atoms, half of them decay. So on the 6th day, you can see they both will have 250 atoms left. So let's check what is the marking, what is the option. So 6th day, C is the right choice. C is the right choice. So question number 40, C is the right choice. I would like to show you one thing. Yeah. You see, I think I have shown you this diagram. This is negatively charged when you bring it near the Y. And what will happen, this side of the Y will become positive. This side of the Y will become negative due to the presence of this negatively charged rod. And due to, and when you earth this side, these electrons here, they will go into the ground, and then you broke the earth, and then you remove this negative charge away. So now here, Y will realize it has deficiency of electrons, so overall it will be positive. So I just thought that I should explain it again. So my dear students, today we have done October, November, and 2010 1-month paper. This was MCQ paper, and this belongs from the zone 1, and I have tried my best to explain the concepts and through my descriptions and by my paperwork. So my dear students, hopefully this video is beneficial to you. If you find this video beneficial, if you find that this video is helping you to improve the concepts of your physics, subscribe to my channel. And if you like this video, also press the like button. And also recommend these videos to your friends, so your friends can also benefit from it. And don't hesitate to comment, because when you comment, whenever I will get the time, I will reply. And your comments and your likes, and they are like energy. You see, for a teacher, the student's response is fuel for a teacher. So keep watching my YouTube channel and improve your physics concepts, and God willing, you will get good grades in your physics CAIE exam 2021. And see you again. So everybody, thank you very